Okay, we are going to look at how to work these problems on your Ohms Law practice sheet. You may generate your own copy from the hub, and yours will have your name on it, both up top and in the watermark. So you need to turn it in that way. Okay, please pause this and take a few minutes to read through the questions. Part of this is comprehension. You're looking for givens, unknowns, and what the scenario is. So hopefully you've paused this, you've read the sheet, and you have understood the questions. Again, doing the math, going through the analysis, and doing the reading at the same time can be a bit challenging. Okay, so we have a couple things. We have a resistor. It is in series with a battery. We have a current, and we are asked to calculate electrical potential. So, we have a resistor, which looks like this. We have a battery, which we draw like this. And we have a circuit. The circuit has a current going through the circuit. Through the circuit, the resistor has a potential, which we call V, across the resistor. These are two important words, through and across. Now, we know the resistor, which we call R, is going to be 25 ohms. Okay? We know that there is a current going through the circuit, through the resistor, of 0.08 amps. Current is normally going to be a small value because if it's a large value, it is actually dangerous. So one normally designs circuits with small values. Not only is it dangerous, but it is more efficient, as we will see on the next practice sheet. Now, what we are looking for is electrical potential across the resistor, which we are going to call V. So we are going to calculate V. Okay? And we're going to use Ohm's law to calculate V. So we are going to use Ohm's law to calculate V. So Ohm's law says V equals I times R. So we know that V equals I is 0.08 amps. R is 25 ohms. And when we multiply that all together, we're going to end up with the 2 volts, which is right here. So 0.08 times 25 is 2 volts. So if you take 0.08 and you multiply by 25, you get 2 volts. Okay. So as you can see, amps times volts or amps times ohms is volts. 2 volts. Okay. Please pause the video. Do number 2. Okay. So you have now completed number 2. So let's move on to number 3. Number 3, we have a resistor and we have a battery. The battery has a potential of 5 volts. We want to calculate the current flowing through the circuit. So we again have a battery connected to a resistor in series. Series means that the same current is flowing through all components. And we know this because they're connected by the same wire. It is not enough for the current to be the same or equal. It's not enough for the current to merely have an equal value. It must be the same current. So our battery has a potential of 5 volts. And again, our resistor has a value of 25 ohms. So our resistor has a value of 25 ohms. And we have a battery, which we call V, of 5 volts. Sometimes you'll see the battery with a fancy E. I'm just going to call it V here because it doesn't matter what letters you give it. It doesn't matter the variable names. All that matters is that we understand. The only complication here is that we have 2 V's. One V is the variable for the battery. The other V is the units that we measure the battery in. And in this case, we are going to look for the current. Okay, we start off with Ohm's law. V equals IR. Now, we are solving for I, not V. So we have to make the equation say I equals. In order to make the equation say I equals, we need to get rid of the variable that is next to the I. The variable next to the I is R. The operation between the I and the R is multiplication. Opposite of multiplication is division. So we are going to divide both sides by R. When we divide both sides by R, we are going to get the equation I equals V over R. Okay, so let me see if we can just do this all together. So we get the equation I equals V over R. V is, the battery is 5 volts, R is 25 ohms. Okay. So let's get rid of that. Let's move this here. So volts divided by ohms is amps. And if you calculate this, 5 divided by 25, you're going to get 0.02. Okay. And that is measured in amps. When we have a battery and a resistor, a current is generated. The resistor is used to regulate the current. The current flows through the resistor. The potential is across the resistor. Through and across are the two words that you need to know. Let me go ahead and highlight those two words. When we have a current, it is flowing through. When we have a potential, it is across. Okay? So go ahead and pause this, do number 4, and come back. Okay. In number 5, you have a resistor. Again, we are in series, which means the same current. It does not mean that it's just the same value. It means that it is literally the same current. And we're going to calculate the value of the resistor. So our circuit is the same. You have a battery, you have a resistor. We are calculating the value of the resistor. We know that the battery is 5 volts, and we are calculating resistor and the battery because it's the same current. Okay, so what do we know? We know that the battery, which we're calling V, is 5 volts. We know that we have a current going through, which is 0.08 amps. The unit for current is amps. The units for electric potential is volts. And the units for resistance is ohms. Ohms is given in a omega. Okay? So that is called an omega. And we're going to calculate the resistance. So we start off with Ohm's law. That in this case, we're calculating R. To calculate R, I have to get rid of everything other than R. And the thing there is I, which is the current. So the current and the resistance are multiplied. The operation between the current and resistance is multiplication. It is multiplied. So the opposite of multiplication is division. So we need to divide both sides by I in order for the equation to look like R equals. And when we do this, we see R equals V over I. So we substitute. We have 5 volts over 0.08 amps. And we see that volts over amps is ohms. Of course, we have ohms because some guy was named Ohms, just like some guy was named Ampere. His name's actually Ampere, not Amp. And so we end up with these names of these units because these are what these people's names are. And we can't do anything about that. We just have to deal with it. And of course, we can't use an ohm. Ohm starts with O. We can't use an O because it would look like a 0 and everyone would be extremely confused. So we use an omega instead. And that's what that symbol for ohm is, an omega. We have 5 divided by 0.08, which gives us 62.5. And again, that is ohms. For ohms, we use an omega. Please do number 6. Please take a little bit longer because we are going to do something a little bit different for number 7. So please take a minute, pause the video. In number 7, we have 2 resistors with 2 different values. Okay? We're now getting into the situation that we did in the first simulation. You should have done this simulation already. So you should already have an idea of what is going to happen here. In your simulation, you saw that when you had 2 resistors, you could make an equivalent circuit. The word here is equivalent circuit. That means that instead of having more than one resistor, you only have one resistor. So, from the simulation, you know that if you have a circuit with 2 resistors, in this case we have a circuit of 15 ohms and 25 ohms, that becomes a circuit of one resistor with 15 plus 25 ohms. Okay? So, you saw this in the first simulation you did for this unit, which hopefully you have already done. So what we do is we call this R1 of 15 ohms. So we're going to say we have an R1 of 15 ohms. Then we're going to have an R2 of 25 ohms. So here we have 2 resistors in series. What does series mean? That they have the same current. It's not enough to have the same value, but it actually has to be the same current, which typically means that it is connected by the same wire. And in this case, we are given the current, and we are looking for the potential. So we are looking for the potential. Okay? So we have Ohm's law, and for a series circuit, we have an equivalent resistor. Okay? So we add the two resistances together. Okay. Oh, it's plus. Okay, so it's just that last ohms. Okay, so this is an ohms. Okay, so the 15 and 25 are the equivalent resistor. Okay, so this is the equivalent resistor, which we call RE. And let's go ahead and put that over here. So V equals 0.8 amps times the equivalent resistor, which is 40 ohms. And if you put that, I'm not sure why I have 3/2 there. I'll fix that on your page. You should make 3.2 volts, 0.08, 40. So 0.08 and 40. Like I said, I'll have the answer fixed. And the units is volts. So the key takeaway on this problem is that when you have resistors in series, which means they have the same current going through them, not just the current of the same value, they just get added together. So it doesn't matter how many you have. Here we have 2, you could have 7, you could have 8, you could have 100. Just add them together, and that is the equivalent resistance. So go ahead, pause this, and work on the last problem. Hopefully you have looked at the last problem. We have Ohm's law, which is V equals IR. V is the electric potential, which in this case is supplied by a battery. I is the current. R is the resistance. Anytime you have a potential cross a resistor, you get a current through the resistor. So a potential across a resistor causes a current through the resistor, and you can calculate any one of these values using algebra and Ohm's law. If you have a resistor in series, you can add them together and get an equivalent circuit. You can always get an equivalent circuit. Submit this as the instruction on your paper. Do not submit this page. This page is only for reference. This video is only for reference. You must generate your own copy with your name and submit it. Thank you.